Hey everyone, welcome to your play posit for this week. We're going to be covering the triangle sum theorem and reviewing different types of lines. So go ahead and grab your notes and we'll get started. I wanted to share with you guys, my daughter had her 7th birthday this past weekend. Lily, right here, she turned 7 and she wanted a unicorn birthday party. So one of the activities that was a surprise, we did like a scavenger hunt and I wrote all the clues. And their task was to find the missing unicorn of Golden Springs. So this is actually my dad's house. He lives in Golden Springs Court. And so this is my husband, Lily's dad, dressed as a unicorn. And they ended up finding him and he like ran through this whole field and around through everybody. It was hilarious. You can like see his face right there. The costume was surprisingly amazing and a really good deal on Amazon. I was shocked at how well it like stayed blowed up. So I just wanted to share that with you. Again, we're going to be covering how to solve triangles for missing angles. This is one of the biggest things that you guys will leave geometry with, and most of you, if not all of you, already know how to do this. So that's a plus. So just a quick review from items that we've been doing this week, both in your OMHS and in live classes. We have 2 lines here and a transversal. And I should tell you that L is parallel to M. We need to know that in order to work with these. And I want us to find X and Y. So we want to use those angle pair relationships. So if you look here, we have a Y and an X. So we can't use these two because that will give us 2 variables. And we can't use these two for the same reason, X and Y. So we really need to focus on the X's first because they're the only 2 that match. And if you remember, these are alternating across that transversal. So these are alternate interior on the inside, and they are congruent. So we're going to set them equal. And here's where we use our algebra skills, right? We're going to combine like terms. So let's get all the x's together. I'll move the 6x over to combine with the 8x. That's 2x minus 31 equals 3. And now we'll move that negative 31 over by adding it. And we get 2x equals 34. Last step is to divide by 2. And x is, what is that, 17? Yeah, x is 17. All right, we found x. Now we just need to find y. So we can use either one of these. Let's plug x in and see what the angle measures are. So 6 times 17 plus 3. I don't have my calculator, so let's do this by hand. We can also do 8 times 17 minus 31, whichever one you guys want to tackle first. Let's see, 8 times 10 is 80. And then 8 times 7 is 56. So 80 plus 56 is 136. So this should be 136 minus 31, which is, and you guys can certainly grab your calculators. I don't have one handy. And hopefully you got 105. Let's try this one. Oh, 6 times 7 is 42. And then 102 plus 3 is 105. We did our math right. So these angles are both 105. Now it's kind of up to you where you want to go from here. These are same side interior or consecutive interior. We know those are supplementary. This is a linear pair. We know those are also supplementary. So let's do 105 plus 5y plus 35 equals 180. Now here we go. We're back to algebra, right? Combine like terms. 105 plus 35 is 140. Now we'll get that y term by itself, so let's move the 140 over. and you get 40. And lastly, divide by 5. And you get 8. So x is 17 and y is 8, and we are finished. We can certainly plug y in here. Let's see, 5 times 8 plus 35. So 40 plus 35 is 75. And sure enough, 105 plus 75 is 180. I wonder how many of you noticed that we actually didn't have to do all of this. We could have just done 180 minus 105, right? Because we know these two add up to 180 and gotten the, so this would have given us 75, right? We still would have to find y. So you could say this equals 75 and solve for y. So either way that your brain saw it. And I hope by now I don't have to remind you guys that you can pause this, pause it at any time. Even if I haven't built in a pause for you, you can pause it, try the questions on your own, and come back for the answers. That's the beauty of the pause, and that's how they're built. All right, so in class on Wednesday this week, we learned all of the different types of angle relationships. And now we're going to talk about the converse of all of those. So remember, converse is the reverse. So in class, we learned that if two lines are parallel, all of those angles exist, right? Well, now we're going to reverse it. If the angles exist and they're, in this case, equal, then the lines are parallel. So in class, we learned about parallel to angles, and now we're doing the converse. So we're going to look at the angles implying parallel. So let's look at the first statement. If two lines are cut by a transversal, so the corresponding angles are blank. So if you look at this picture, 2 and 6 are corresponding, and they are congruent. If those angles are congruent, then we know the lines are parallel. They have to be. So in this example, they want us to show M and N are parallel. Well, if they are, then we know these are going to be equal. So let's see. Minus 5, minus 5. If we get an x value that we plug in and they're equal, then we know the lines are parallel. So x is 20. Plug in the x, and you do get 65. So because we showed the lines are, or the angles are equal, we showed or proved M is parallel to N. And you might be going, well, duh, Miss Winslow, that makes sense. And you're right. A lot of the times when we look at the converse, it's sort of intuitive. It makes complete sense. So these angle pair relationships work both ways. Look at the next one. Alternate interior angles converse. If the two lines are cut by a transversal, so these are equal, congruent, then the lines are, of course, parallel. So instead of knowing they're parallel and being able to show that they're equal, the angles, we're going to show the angles are equal, which will prove they're parallel. All right, let's see. 2x plus 20 equals 3x. We know these are alternate interior, and they are congruent. So I'll just subtract the 2x this time. X is 20. Let's see. 2 times 20 plus 20. That is 60. And 3 times 20 is 60. M is parallel to N. Remember, this is the shorthand for parallel. It's like the two L's in parallel. I wonder if mathematicians really chose it because of that. That's kind of one of those things that makes you go, oh, right? It's kind of like a little creepy because these lines are obviously parallel while we're making them. They don't touch and they look parallel. And then in the word parallel, there are the two L's. Ooh. All right, alternate exteriors. Very similar to alternate interiors, except of course these are on the outside. If they are congruent, then the lines are, you guessed it, parallel. So let's see, 180 minus x equals x. So I'll add x to both sides. 180 equals 2x and divide by 2. X is 90. All right, x is 90 and 180 minus 90 is 90. So M and N are parallel and that transversal is perpendicular. That's interesting. Where parallel and perpendicular lines exist in the same space. Consecutive interior angles converse. If the two lines are cut by this transversal, so the consecutive interior angles are, remember this is also known as same side interior angles theorem. These are supplementary. Don't forget, the angles that we're talking about here are either equal or supplementary, one or the other. Guess what? The lines are parallel. So we'll do this supplementary. They add up to 180. Combine like terms. 150 minus 15, that's 135. We'll subtract 135. That's 45, right? Yeah. Divide by 3. X equals 15. 3 times 15 minus 15. 45 minus 15 is 30. And sure enough, 150 plus 30 is 180. So those are supplementary. That was our last angle pair relationship converse theorem, if you will. And now we're going to look at the transitive property. The transitive property appears so frequently in math. You learned this so long ago. It's this one. If A equals B and B equals C, then A equals C. Remember this one? And you can see, like, if the two match, then of course these are going to be equal. So this is similar. We're talking about parallel lines. If two lines are parallel, then they are parallel to each other. So for example, if P is parallel to Q and Q is parallel to R, then of course P will be parallel to R. So if these are parallel, these two, and Q is parallel to R, then of course the first is going to be parallel to the last. The transitive property holds true. This just becomes really helpful in those diagrams that has those multiple parallel lines with multiple transversals. All right, moving right into triangles. So when you're talking about triangles, we have interior angles and exterior angles. And I don't think I need to read this formula or this definition for you guys, but the angles that are formed when you draw like a traditional triangle with those vertices are the interior angles. These are the ones we're used to seeing and used to talking about. In geometry, we're going to extend the edges of the shape. And when we do that, we have what are called exterior angles that are formed, angles on the outside. The angles that form linear pairs with the interior angles are the exterior angles. And they do form linear pairs. See? This is that interior angle, and it's forming a linear pair with the exterior angle. They all form linear pairs. So this is going to be really helpful when they ask us to solve for interior and exterior angles. The triangle sum theorem. We're going to use this so often, you probably already have. The sum of the interior angles is always 180 degrees. We've talked about this before. So let's solve for x. all we're going to do is take all the three angles and add them together and set it equal to 180. And if you think about this, if you were to imagine separating the edges of this triangle and forming a straight line, right? You can imagine this side coming down, this side coming down, kind of unfolding, right? And it forms this straight line. How many angles are on a straight line? How many degrees? 180. And why do we know that? Like, where does this even come from? You know, we talk about the why. And I can tell you this theorem and you can believe me, or you can see where it comes from. And I know we've talked about this a little bit. It comes from cutting a circle in half. We know there's 360 degrees in a circle. You cut it right down the middle with that straight line. It gives us the 180 degrees, which again is like unfolding that triangle to make the straight line. So that's pretty cool. Let's find x. 3 plus 2 plus 1 is 6. Right? So then we'll divide by 6. X equals 30. X is 30. We're going to do this so often in here, we're going to be using the triangle sum theorem to find missing angles. The other theorem we're going to use is involving the exterior angles. And it tells us that the measure of this exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. So that's a fancy definition. Let's talk about it. Here's the exterior angle. The remote interior angles are going to be the angles directly across from him or her, it. This angle. So angle A and angle B in this example are called the remote interior angles. If I had a triangle drawn like this, then for this exterior angle, these are the remote interior. If I drew it like this, for this exterior angle, it's these two. So it's the two angles across from it, never the angle right next to it. And all you do is you add these two up. So to find ACD, we're going to add angle A plus angle B. And that's it. And I'll show you why it works in a second. So down here, to find angle Y, all you do is take 70 plus 88. What is that? 158. Now there's another way to solve this problem. And this is why it works. So let me grab my pencil a different color. Remember the triangle sum theorem? We can find this angle, can't we? 70 plus 88 is 158, right? Well, if there's 180 degrees in a triangle, and there's already 158, then to find it, we just subtract. What is that? 58, 68, 78, 22, right? So this is 22 degrees. Hey, look, isn't this a linear pair? So to find a linear pair, like always, we would do 180 minus 22. Guess what that is? 158, which is exactly what we got when we applied the exterior angle theorem. So it's really just another way to use the triangle sum theorem combined with the linear pair theorem. And that's why it works, because in both cases, you're subtracting from 180. Okay. Now, in this case, we couldn't use this technique because we only know one angle measure. So let's use the exterior angle theorem. We know the outside angle equals the two across from it added together. So 3x minus 22 equals 80 plus x. 80 plus x. Now let's solve for x. I'll subtract x from both sides. and add 22. This is 58 and divide by 2. What is this? 29, I think. X is 29, but it wants us to be careful. It wants us to solve for ACB. So ACB happens to be that interior angle, this one right here. So we have a few options, right? We could take this X, plug it in here. This is 29. And then take these and subtract from 180. That would work. Or you could plug X in here and subtract from 180 because that's a linear pair. Let's do this. So 80 plus 29, we're going to take that and subtract it from 180. What is that? 109. So 180 minus 109. This is when my brain freezes a little because I'm like, okay, I know it's going to be basically 80 minus 9, which is 71. There we go. 71 degrees. All right, let's find all the missing angle measures. So we're going to work ourselves through the picture. Here we have two angles, so let's find the third. 14 plus 45. 59. This one is 59. Now we know these are vertical angles, right? So if this is 59, this one must be 59. And now we can do the same thing. Once you have two, you can always find the third. 27 plus 59. 86. There we go. So we worked our way through the picture. Not too bad. Let's wrap this up with some other lines and planes. So we're going to talk about oblique lines. Oblique lines are lines that are not parallel and they are not perpendicular. So we've been talking about that a lot with slopes lately, you know, where we say it's neither. So examples of lines like that might be this, for example. You can see those are definitely not parallel because they're crossing, and they're not perpendicular because it's definitely not at a 90-degree angle. So this is an example of oblique lines. I do not know of a symbol for oblique, like parallel and perpendicular has. Next are skew lines. Skew lines do not intersect, and they're not in the same plane. Just a single skew line is like a slanted line. That's kind of the definition, a line that is slanted. But when we're talking about a pair of skewed lines or multiple skewed lines, it would just be lines that do not intersect and they're not in the same plane. So it's kind of hard to draw. We could draw like some parts of a cube and maybe there's a line here and there's a line here. You can see they're not on the same plane and they're not intersecting. Parallel planes are super intuitive. They're really similar to parallel lines. You can imagine like the top of this box, we could call that plane ABC is parallel to plane, we could say EHG. The top and the bottom. So the planes do not intersect, and essentially the planes have the same slope. The lines and the planes have the same slope. That's just one example. Of course, you have the two sides and the front and the back. So let's try these. Name all the segments parallel to AD. AD is right here. So it's going to be BC, GF, and EH. BC, GF. They're parallel on that diagonal plane. And EH. Number 2, name all the segments perpendicular to AD. So all those that meet at that 90-degree angle, and we know it's 90 degrees because it's a cube. Even though I didn't tell you, I'm going to tell you now. It is a cube. So we have AE meets it there at that 90 degrees. DH, certainly. DC, and AB. These are all segments. Sorry, I don't have all the little segments written above. Number 3, name all the segments skew to AD. Here, AD is on this plane. So like EF would be a good example, HG and EF. Not GF because that's on that parallel or that diagonal plane. And number 4, name all parallel planes to ADC. ADC. So that's the top of the box, just like we talked about in the last one. So we could say plane EH. My pencil is dying. Do you guys see that? It's like I'm done working for today. EHG. There we go. Disregard. Okay, I have a task for you. I'm going to post this link. Hopefully it'll pop up in the play pause it for you. And I would love for you guys to take a picture in your home, in your neighborhood, in your world, in your environment that shows triangles and or angles. This is a playground in a park near us. This is my husband George, the unicorn. Remember him? My daughter is inside this tube right here. It's kind of hard to see, and she's going to slide down in a minute. Whee! But this playground was insane. You can see all the different angles and shapes being formed by the equipment. So I thought that was really cool. So I would love for you guys to come to this Padlet and post a picture. You don't have to be in it. That's not a requirement. But to post a picture of triangles in your world or angles in your world, anything that you see around you. I would love for you to do that. I hope that you have a wonderful fall break and you do lots of relaxing things in your home, with your family, with your friends, with your neighbors. And please continue to reach out. And if you guys need anything, we'll be in office next week on Monday and Tuesday. And then I will see you guys after the break. If you do celebrate Thanksgiving, I wish you a wonderful Thanksgiving with your family. And if you don't, I still wish you a fabulous fall break full of lots of relaxation and rest. And I'll see you guys very soon. Bye, everybody.